half of that to go. Who will come out on top?
Types of redox reactions. Not all chemical reactions are redox reactions. For the example, acid-base reactions and double decomposition reactions are non-redox reactions. Four examples of redox reactions are: number 1, changing of iron 2 ions to iron 3 ions and vice versa. Number 2, displacement of metal from its salt solution. Number 3, displacement of halogen from its halide solution. And number 4, transfer of electrons at a distance. Changing of iron 2 ions to iron 3 ions and vice versa. In this changing, iron exhibits two oxidation numbers, positive 2 as iron 2 ions and positive 3 as iron 3 ions. An aqueous solution containing iron 2 ions is pale green in color, where an aqueous solution containing iron 3 ions is yellow or brown in color. Changing iron 2 ions to iron 3 ions is an oxidation and therefore requires an oxidizing agent. Example of oxidizing agent that can be used are bromine water, chlorine water, acidified potassium manganate 7 solution, acidified potassium dichromate 6 solutions, hydrogen peroxide, and concentrated nitric acid. To investigate oxidation and reduction in the change of iron 2 ions to iron 3 ions. In terms of redox reaction, we can explain that the bromine water oxidizes iron 2 ions to iron 3 ions. The presence of iron 3 ions can be confirmed by the formation of brown precipitate with sodium hydroxide solution. Iron 2 ions lose their 1 electron and are oxidized to iron 3 ions. Bromine molecule, which give the bromine water its brown color, gain the electrons and reduce to colorless bromide ion. This is why the bromine water is decolorized. The conclusion, based on the investigation, bromine water acts as an oxidizing agent, changing iron 2 ions to iron 3 ions. To investigate oxidation and reduction in the change of iron 3 ions to iron 2 ions. In this reaction, zinc powder reduce iron 3 ions to iron 2 ions. The presence of iron 2 ions is confirmed by the formation of green precipitate with sodium hydroxide solution. Zinc atoms lose their 2 electrons and oxidize to zinc ion. This explains why zinc powder dissolves in iron 3 sulfate solution. Iron 3 ions accept the electrons and reduce to iron 2 ions. In this reaction, iron 3 ions act as the oxidizing agent, where zinc metal act as the reducing agent. Displacement of metal from its salt solution. Metal are good electron donors and therefore are good reducing agents. Different metals have different strength as reducing agents. The strength of metals as reducing agents can be compared by using the electrochemical series. The electrochemical series lists metals according to their electropositivity, according to their ability to lose electrons to form positive ions. The higher the position of a metal in electrochemical series, the more electropositive the metal is. The easier it is for the metal to lose its electron, the better reducing agent the metal is. The ability of a metal ion to accept electron increases down the series in electrochemical series. The strength of a metal ion as an oxidizing agent increases down the electrochemical series. In a displacement of metal, a more electropositive metal will displace a less electropositive metal from its salt solution. The more electropositive metal acts as the reducing agent. It loses electrons and undergoes oxidation to form positive ions. The ions of the less electropositive metal act as an oxidizing agent by accepting the electrons. The ions are reduced to metallic atoms. There is an electron transfer from the more electropositive metal to the ions of the less electropositive metal. In test tube X, zinc atom displaces copper to ion from copper to sulfate solution. Zinc is more electropositive than copper, so zinc metal acts as the reducing agent. Zinc atom losing 2 electrons to form zinc ion. So, zinc metal is oxidized. This explains why the zinc strip dissolves. The 2 electrons are accepted by copper to ion in copper to sulfate solution. Copper to ion act as the oxidizing agent, and copper to ion are reduced to metallic copper. The observation, the brown solid deposited in test tube X, so the brown solid is copper metal. When the number of copper to ion decreases or the concentration of copper to ion in the solution decreases, so it causes the solution slowly change color from blue to colorless. Or we can say that the blue color of copper to sulfate solution turn to colorless or become paler to colorless. In test tube Y, copper atom displays silver ion from silver nitrate solution. Copper is more electropositive than silver, so copper metal acts as the reducing agent because copper atom losing its 2 electrons to form copper to ion. So copper metal is oxidized. This explains why the copper strip dissolves. Silver nitrate solution is colorless, but the increasing the number of copper to ion in the solution cause the solution slowly change color from colorless to blue. The 2 electrons are accepted by silver ion in the solution. So silver ion act as the oxidizing agent, and silver ion are reduced to silvery gray silver. We can make the conclusion that a more electropositive metal can displace a less electropositive metal from its solution. The more electropositive metal will act as the reducing agent, and the ions of the less electropositive metal will act as the oxidizing agent. Displacement of halogen from its halide solution. Halogens are good electron acceptors and therefore are good oxidizing agents. When going down group 17 of element, the size of the halogen atoms increases. The distance between nucleus with its valence electron at the outermost shell increases. So the ability of the atom to accept or receive electrons to form halide ions decreases. The electronegativity of the halogen decreases. To investigate oxidation and reduction in displacement of halogen from its halide solution, a few tips here. A more electronegative halogen will displace a less electronegative halogen from its halide solution. Halide ion of less electronegative halogen will transfer electrons to more electronegative halogen. To investigate oxidation and reduction reaction based on transfer of electrons at a distance. Electrons are transferred from the reducing agent to the oxidizing agent. When the reducing and oxidizing agents are separated by an electrolyte in a U-tube, the transfer of electrons occurs through the connecting wires and can be detected by a galvanometer. Electrolyte allows the movement of ions to take place, thus completing the electric circuit. This to ensure a continuous flow of electrons in the external circuit.